All right, so here's the proof of theorem 3-1, and take note of this because you're going to prove 3-2 on the assignment, and it's very similar proof. So, all right, so we want to prove that if a transversal crosses two parallel lines, then the alternate interior angles are congruent, right? So if we want to prove that, we're given the hypothesis, we want to prove the conclusion. So that's how you prove a theorem, right? Is you take the hypothesis as given and you prove that if that's true, then the conclusion must follow, right? And so deductive reasoning. So we're going to start out with the given. So I'm going to say line J is parallel with line K. That's a given. All right. And then I know when I have a transversal that crosses two parallel lines, I know that their same side interior angles are supplementary, right? By the same side interior postulate, right? That we saw on the first slide, right? So if a transversal intersects two parallel lines, same side interior angles are supplementary, right? So I can go back here and say, okay, well, angle 3, right, is congruent, or excuse me, is supplementary. Or let me do angle 3 and angle 6 are supplementary. Okay, and we can say that by postulate 3-1 or same side let me put interior angles postulate, right? Okay. All right, so now we also know that just from the diagram that angle 3 and 4 must be supplementary, right? Because they're on their same side, or excuse me, they're a linear pair, I should say. So angle 3 and angle 4 are supplementary. Reason, definition of linear pair, right? Let me actually revise that. It's a linear pair postulate. So, all right. And so now we know, and with another theorem, that if we have two angles that are supplementary to the same angle, then they must be congruent, right? So angle 6 must be congruent with angle 4, right? Because of the congruent supplements theorem. So congruent supplements theorem. I'll abbreviate here. Okay. All right, and we just proved what we set out to prove, right? That alternate interior angles are congruent. And we used the same side interior postulate, right? And then we also used our linear pair postulate in this case.